Good evening, friends. Today, after a long break, we are again continuing this model-based system approach, model-based system development. So, we will be discussing today about one research paper. The title is Jointly Modeling Spatiotemporal Dependencies and Daily Flow Correlations for Crowd Flow Predictions. This paper appears in the knowledge knowledge discovery from ACM transaction or knowledge discovery from data, volume 15, number 4, article 58, publication date March 2021. So in this lecture, we'll be discussing how this the paper is. We are considering this paper as a system, so it has different component. So it's basically this paper is basically for modeling crowd flow prediction. So there is a map where four locations are identified A, B, C, D. So with that location on the map, there is there is a large number of data set has been collected for the bike and taxi flows for over the 10-15 years. Data they have collected, and that analyzing that data are using this how this crowd flow can be discovered. So these two data sets are basically from the open source data space. So the database, this paper is open, not open, but it's in the Sky Hub. I found it open, but otherwise it is not open. So the two links of the dataset has been given: https colon double slash www citybike citybikenyc.com slash system dot dash data. So on the paper these links are given. And this is for the bike data, and another one is for taxi data. So they have divided the entire paper into first is obviously with that introduction part. It discusses about the importance of spatial data, importance of finding the crowd flow predictions. So in the first line of the abstract, they are stating why this study is important. So they are telling that the crowd flow prediction is a vital problem for an intelligent transportation system construction in a smart city. It plays a crucial role in traffic management and behavioral analysis. Thus, it has raised great attention from many researchers. So, in this paper, after the abstract, there is introduction in the first section. Then, second section, in the first section, they are showing one maps with the caption two examples of daily flow correlations between regions A, daily inflows of the two residential regions A and B. So A and B's are the residential regions, and how the daily flow are correlated. And the second locations, the daily inflows of the two regions C and D, which are connected by a main road. So C and D are the two other regions, or some maybe the of mall or that kind of thing. So these two regions, how are they connected by the main road? They are connected by the main road, and how the data are correlated. So basically, we are not going to the detail of the research. In this lecture, we'll just highlight what are the components. So after introduction, they are talking about related work. Then they have divided into 2.1 that talks about traditional methods for crowd flow predictions, 2.2 deep learning based crowd flow predictions, and then 2.3 other traffic related predictions talks. So this is the review of literature, and 2.4 is also there, multi-step time series predictions. So in the second section, they have talked about the review of literatures, and there 5 subsections are there. So in the third, they are talking about the preliminaries, how they are defining the problem. The mathematical things are flowing here. Then on the third sections is smaller, so there are three definitions are there. Then formal problem formulation is also stated. In the fourth, double encoder problem, double dash encoder model. So there is a figure, then 4.1 overview, 4.2 the ST encoder module, and there are subsections. 4.3 the FR encoder module. So like that it goes, and then the 4.4 decoder module, and 4.5 model learning. 5 shows the experiment, then 5.1 data sets. So bike NYC, taxi NYC, reference spawn, and 2. 5.2 baselines, various models has been discussed for 4 to 5. Then 5.3 experimental settings, 5.4 evaluation metric, 5.5 experimental results, and there are table 2 performance comparison between different models. So their models double encoder found to be more efficient. Then graphs, figure 3 comparing the graph RMSE of the different models. So similarly, results of stepwise predictions and results of each day predictions. So they have through bar diagram and line graph they have compared. Then ultimately this for taxi data and bike data, validation of the region embedding length. So those things they have discussed. Figure 6 is also there. There are discussion and conclusion. Then there are references. So 53 references they have cited. So in the next lecture we'll be discussing how this all the literature 53 references, how can we shortly described in a paper, and this paper. So we are not going to detailed discussion, we'll only highlight what are the key features of those references. Thank you.